Hey guys, here's another video showing an example of how to find a horizontal asymptote, but we're going to kick it up a notch and go with something a little more complicated than the example in the intro. So suppose you have this function instead, square root 9x squared minus x all over x plus 1. So in this example, we're going to follow the same kind of procedure that we did before, but it's going to get a little more complicated because of that square root. So let's just kind of go through the process and sort of see what happens. So hopefully you remember from the other video that we are still looking for a limit. We're going to look for the limit as x approaches infinity for this function here. So this is the setup. Limit as x goes to infinity, square root 9x squared minus x over x plus 1. And if you remember, the first step was to figure out what the highest power of x is in the denominator. In this case, it is x. I think it was x last time as well, x to the first. And you might get a little mixed up by looking at the numerator. You see x squared, but we're still not really looking up there. We should be looking in the denominator regardless. But if you're looking at the x squared, notice that it still is a square root. So the highest power of x in the numerator does happen to also be x. But again, that's not going to affect our process because we're looking down here. So our first step, or our next step, last time was to actually divide the numerator and denominator by x. So divide by x all over x plus 1 divided by x. And if you remember, we took that and then simplified a little bit. So the denominator is going to be pretty straightforward, kind of like what we've already done. This is x over x, which is 1 plus 1 over x. That's the simplified denominator. The numerator's got a little bit of a twist to it. I can't just divide 9x squared by x. I can't just divide x by x because that's not what this is. This isn't 9x squared. It's the square root of 9x squared. The only way to get this x inside the square root so that I can simplify it here is to actually square it, because the square root of x squared gets me back to the original x that I'm dividing by. So watch. If I actually, let's make a big square root here, 9x squared minus x over x squared. That's the only way to get that into the square root, is to actually square it. Now, you may say, but I'm doing something different. I'm not. The square root of 9x squared minus x is still the same thing. The square root of x squared is x. Now, what you really should be thinking about is, Mr. Miller, I thought we learned that when you take a square root, you have to do plus or minus. That's an excellent thought. I'm so glad you said it. Well, in this case, I am going to positive infinity. So I'm only going to use the positive root for the square root of x squared. Spoiler alert, when we go to negative infinity, that's when the negative is going to come into play. All right, but for right now, we're still just using the positive root. So now we can simplify. This becomes the square root, 9x squared over x squared is 9, and minus x over x squared is 1 over x, all over 1 plus 1 over x. So I simplified, I did it in kind of one step here. 9x squared over x squared cancels to 9. Negative x over x squared cancels to minus 1 over x. And as x goes to infinity, if you remember, the 1 over x goes to 0, the 1 over x goes to 0, and you're left with the square root of 9 over 1, which is 3. So we have a horizontal asymptote at y equals 3. That's not the only one. If we do this same process, the limit as x goes to negative infinity of this, 9x squared minus x over x plus 1, all the steps are the same. I'm going to do the same steps that I did all the way through, with one exception when I get to here. So my next step would be same thing, square root of 9x squared minus x over x divided by x plus 1 over x. And then here's the real key step. To bring this x inside, I'm still going to do the square root of x squared. But because I forgot the negative here. Because I'm going to negative infinity, I have to use the negative root for when I do the square root of x squared. So watch. It's going to actually look like this. Goes to negative infinity. And this is going to be square root. Here, I'll even separate it as its own little step. Divided by negative square root x squared. And I'll explain that again. and this becomes, I'll just keep this the same for now. And I realize I'm kind of running out of room. I'll do it down here. Watch right here. This is the key step that's different here and here. This is the positive root. This is the negative root. And I'm just focusing on this one part. If x is going to negative infinity, so let's say negative 10, negative 100, negative 1,000. If I square that, I'm going to get a positive number. So when I take the square root of that positive number, I'm going to get a positive number. But I'm supposed to be plugging in negative numbers. The only way to force this root to be negative is to take the negative version of it. But Mr. Miller, why don't you put a negative down here? I don't have to put a negative down here. X is already negative. As x approaches negative 1 billion, I'm already plugging in negative 1 billion down here. I'm already plugging in negative 1 billion here. The only time it gets messed up is when I try to plug it in here. That's the difference. That's what changes. So if I clean that all up, and again, sorry for the spacing, let's just do it right down here. I'm going to get the limit as x goes to negative infinity. This, I'll bring it inside now. So I have a negative big square root, 9x squared minus x over x squared, all over x plus 1 over x. So you can kind of see the similarity to what we've already done, with the one slight difference of this being a negative root. So rinse and repeat what we did before. This becomes negative square root of 9 minus 1 over x over 1 plus 1 over x. These parts go to 0, and I'm left with negative square root of 9, which is negative 3, over 1, which is negative 3. So I'm going to have another horizontal asymptote at y equals negative 3. I have two of them, two horizontal asymptotes that are different. So as x goes to positive infinity, the graph is going to approach 3, but while x goes to negative infinity, the graph's going to approach negative 3. Which seems kind of crazy that they're different, but that's just the way this graph looks. Let's actually take a look and see what it looks like. This is square root, so I'll use parentheses here to be safe. Square root 9x squared minus x, close parentheses, divided by x plus 1. Okay, there's my graph. I'll make my window. I'll just do a zoom 6, which is a standard window. And now you can kind of see it. As x approaches negative infinity, this graph is approaching negative 3. As x approaches positive infinity, this graph approaches positive 3. And you might even say, Mr. Miller, though, isn't the value of the curve 3 like right about here? How can it be an asymptote? A horizontal asymptote, all I care about is what's happening as x is approaching positive infinity or negative infinity. I don't care what's happening in between. I want to know what's happening all the way at the end. That's why it's called end behavior. So it's happening all the way at the end. This graph is approaching 3. This graph going this direction is approaching negative 3. And that's the horizontal asymptotes for this graph. You might also notice, just as a side note, there is a vertical asymptote here, which kind of makes sense because when x is negative 1, this function would be undefined. It'd have infinite slope. So that's why you have a vertical one there. But focus your eyes on the horizontal for now for the purposes of this conversation. And that's why we have two different ones. And here's the work to justify it. So just be careful when there's square roots. That's really the only place you're going to potentially have this issue of the negative. So that's what you want to watch out for, and use this as your example to kind of get you through those. All right, hopefully that helps. And be sure and let me know if you have any questions. And I'll see you guys later.